Hey guys, I'm going to go over how to do all of these problems. All right, from the homework, remember you only do the odds. All right, you're going to be having a quiz coming up on this type of stuff, all the graphing rationals, solving inequalities by hand, and solving the inequalities on a calculator. All right, I know we were supposed to have a chapter test, but we are not going to do that. It's just going to be a quiz on the stuff you have not been quizzed on yet. All right, so here we notice the degree is larger on top than the bottom. So this is a case where we're going to have either a slant or a hole. There's nothing I can do with the top, so I'm not going to be able to cancel anything out, which means we are going to have a slant asymptote. All right, so we go through our steps. Vertical asymptotes at the bottom equals 0. I get x equals 3. This is going to be a slant, so I divide. I can do synthetic, which means I put 3 in the box. I have -1, 5, and -5. I go through and do my synthetic. I bring down the -1. That becomes a -3. 5 and -3 is 2. And then I'm done because I don't care about the remainder. So my slant asymptote is going to be y equals -x plus 2. I get that right from here. This is my constant. That is my coefficient of my x. All right, x-intercept. All right, x-intercept for this one is a little bit of a pain. All right, because when you set this equal to 0, we just said before, we can't factor this. All right, so for this problem, you either are going to have to use the quadratic formula or completing the square. All right, maybe the quadratic formula would be a little bit easier because you don't have to deal with an odd number here, a fraction. You guys can do whatever you want, but you just go through and do complete the square. And I'm just going to write the answer here, and so otherwise we'll be here for another like 5 minutes doing this problem. All right, so I'm just going to put the answer down for what the x-intercept should be. So you get 5 plus or minus the square root of 5 over 2. All right, 5 plus or minus square root of 5 all over 2, comma, 0. All right, that is your x-intercept. Now, to do your y-intercept, we're going to plug in 0 there, we plug in 0 there, we plug in 0 there, we get -5 over 3, -5 over -3, which is 5/3. All right. All right, so now let's go through and graph our asymptotes. So I got x equals 3. My slant asymptote is -x plus 2. So, all right, start with, there's my y-intercept. It's down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. Just do a little bit just to make sure it points. All right, so it's supposed to be straight, but sorry about that. Okay. All right, so we have those. Now let's graph points. Let's see. All right, now plus or minus, let's do 0, 5/3 first. 0, 5/3. This is at 2, which means it's less than that. So it's down there somewhere. It doesn't have to be exact point. It's there. All right, now 5 plus or minus root 5 over 2. If we think about this, root 5 is a little bit bigger than 2, right? So if I did, like, let's say like 2.1, just to make it easy. If I did 5 plus 2.1, that's like 7.1. 7.1 divided by 2 is somewhere between 3 and 4. All right, so it's in here somewhere. All right, if I do 5 minus 2.1, that is like 3.1 divided by 2, which is somewhere between 1 and 2, which is also here. So all of those points, it makes sense that we have a curve here. These points don't have to be exact. There should be the one over here, and both those points are in this. It's a little hard to see here because I didn't make this the straightest line you've ever seen in your world, in your life, but looks just like that. All right. All right, and there is no symmetry for this problem. There is none. All right, so there you go for number 1. All right, let's take a look at number 3. All right, so for number 3, we look, the degree is less on the bottom. Love when it's less on the bottom because it's automatically horizontal asymptote, and it's always y, sorry, I didn't mean less on the bottom, it's greater on the bottom. All right, so it's y equals 0. The 2 is bigger. Whenever it's larger on the bottom, it's automatically y equals 0. All right, vertical asymptote, x squared plus 1. There's nothing that's going to make this equal to 0. All right, because I can't factor that. If I make that equal to -1, I take the square root of -1, it's imaginary. It's plus or minus I. So there is no vertical asymptote. All right, this is going to be one of those special ones that we did an example of in class yesterday. All right, so with this one, for x-intercepts at the top equal to 0, and I get 0, 0, which means the y-intercept will be the same thing, but you plug in 0, you get 0 over 1, which is 0, 0. All right, so this is one of the examples where you have a horizontal asymptote, but you don't have a vertical asymptote. All right, and we have a point at 0, 0. Now, it is okay to cross only if it's right around the origin. But as you get to infinity on either side, negative infinity, positive infinity, it's going to come back to the asymptote. So what we need to do is we need to test a few points, all right? Like 1, 2, and 3, and see what happens, all right? 1, -1, -2, -3. All right, so if I plug in 1, I get 1 over 2, which is a half, all right? So that I have a point that's going to be 1 comma half, which is right here. If I plug in 2, I get 2 over 5, which is 2/5. All right, so I have, this is 1/2, 2/5. What's bigger? So I got a half. All right, so I have 1 comma half, and then I have 2 comma 2/5. All right, well, 2/5 is like 0.4, 1/2 is 0.5. This one's bigger than that. So I'm already back on my way down. So I reach my peak, and now I'm going to come back down, and it's going to look like that. All right, it's going to keep getting closer and closer to 0. I mean, you can plug in 3, you would get 3 over 10. Plug in 4, you get 4 over 17. It's getting closer and closer to 0. All right, now here for -1, when I plug in -1, I would get -1 over 2, which is -1/2. So I'm like, if let's say this is 1, here's my -1/2 right here. And then I'm going to get -2/5. So I'm on my way back down over here. So come like this, coming back up, and it looks just like that. All right, so if I were to rotate this 180 degrees, it's symmetric about the origin, which means this is odd symmetry. All right, that is some odd symmetry. All right, and there's number 3. All right, so number 5, degree larger on the top than it is on the bottom. So this could either be a slant or a hole. The top looks like it factors. Let's check. It does. It's x minus 4 and x plus 1. And it just so happens that those cancel, which means this is a case where we have a hole. So we are now left with y equals x plus 1. This is what we are going to graph, and it's just going to have a hole in it. So it's going to be a line with a hole in it, which means there is no vertical asymptote. Okay, there is no vertical asymptote. Now, to figure out where the hole is going to be, you have to look what got crossed off, what factor. X minus 4 got canceled out. What makes that equal to 0? 4 does. So that is the x coordinate of my hole. To get the y coordinate, I plug that x coordinate into what's left, which is y equals x plus 1. 4 plus 1 is 5. So I have a hole at 4 comma 5. My x-intercept, set this equal to 0, which is mean -1. So I get -1 comma 0. The y-intercept is 1, so it's 0 comma 1. Right? So I'm going to go through and graph 0, 1, which is here, and -1 comma 0, which is there. And I have here and here. Once you have those 2 points, don't have to just, well, that's not a little straight, sorry. Just graph that line and then put, where would the hole roughly be? 4, 5, in here somewhere. Draw an open circle, and there's our hole at 4 comma 5. That's all you got to do. All right, just use your intercepts to make a line, and then put the hole roughly where it should be. As long as I see it here, you're going to be in good shape. This is no symmetry. All right, there's number 5. All right, so here is number 7. All right, here's number 7. All right, so the degree is larger on the bottom than it is on the top. All right, so what's going to happen is we're going to have a horizontal asymptote here. But this is a special little guy. So let's look what happens here. All right. So what we should do is this. We should always look to factor if we can, which we can. And we get x plus 2 and x minus 1. Cancel, cancel. We had things cancel out. What happens when a factor cancels out on the top and the bottom? It means we have a whole. All right. We have a whole. However, we're not left with just like x plus 3 or x plus 2. We're left with 1 over x plus 2. All right. So this is, all right. So this is also going to have a horizontal asymptote. So we're going to have a horizontal asymptote at y equals 0. All right. Because the degree is larger on the bottom. However, we also have a whole. And where's our whole going to be? Well, what canceled out here? The x minus 1. So we're going to have a whole at 1, comma. We plug the 1 into what's left here, and we get 1 plus 2, which is 3, so we get 1 over 3. 1 comma a third is going to be a whole. All right, so this is going to be a little different looking graph with a hole in it. It's not going to be a line with a hole in it. So even though we have a hole, we still have a vertical asymptote because we're left with something on the bottom, x plus 2, which means x equals negative 2 is going to be our vertical asymptote. Our x-intercept, we set the top equal to 0. It's not 1. We set this equal to 0. It's none. There is none. All right. There is no x-intercept. Y-intercept, we plug in 0, and we're left with a half, right? Put a 0 there. It's 1 over 2. So 0, comma, a half. All right. So what we're going to do is let's graph this like we normally would. Don't worry about this hole until the end. All right. So let's go and graph our vertical asymptote, which is at x equals negative 2. All right. And let's graph a horizontal at y equals 0. All right. We have a point at, let's see, this color, 0, comma 1/2. So notice we have 1, 2, 3, 4. We have our 4 quadrants. We don't have, so we need a curve on the right. It's either in this one or that one. Since I have a point there, it has to be there somewhere. All right. Looks like that. Now, to figure out where the other curve is going to go, whether it's in the top one or the bottom one, this is at negative 2. So let's plug in negative 3. Just plug it into here. If I plug in negative 3, I would get 1 over negative 1, which is down here. It's negative 1. So my curve is down there like that. You don't actually have to graph the point. Now, the only other thing we have to worry about is where's our hole? 1, which is roughly here, comma a third. And there is our hole at 1, comma 1/3. All right. So when you have a hole, you just graph whatever's left and put the hole at that point. All right. That's all you have to do. All right. So there's number 7. All right. Number 9. Number 9. Looks like we got a degree larger on the bottom, so we're probably gonna have a horizontal asymptote at x at y equals 0. But let's just factor this first. Notice you can take out an x and it becomes x squared minus 9. But then it becomes x minus 3, x plus 3. All right. So you're left with 2x minus 1 over x times x minus 3, x plus 3. Nothing cancels. All right. The degree is larger on the bottom. All right. So it's just y equals 0 for horizontal. However, vertical asymptote, there's 3 things that make this equal to 0. We have x equals 0, and we have x equals plus or minus 3. So we are going to have 3 vertical asymptotes. All right, we haven't had one like that, but we're going to treat it just like we did with 2. I'll show you that in a second. All right, x-intercept, we are going to set the top equal to 0. And when I do that, 2x minus 1, set that equal to 0. And I get 1/2, comma 0. The y-intercept, if I plug 0 in for everything, I get 0 on the bottom. 0 times anything. Once I do that 0, it doesn't matter what comes here, I get 0. So there is no y-intercept, which also makes sense because the vertical asymptote, there's a vertical asymptote at x equals 0, which means you can't have a y-intercept. All right, so what's this graph going to look like? Well, we have a horizontal asymptote at y equals 0. I have a vertical asymptote there. Let's 1, 2, 3. So let's put one at x equals 3. And let's put 1, 2, 3. Try to leave some nice space around here. Didn't really go through there, but you get the idea. Okay. Now, x-intercept. All right. X-intercept is at 1/2 comma 0. All right. 1/2 comma 0, which is right here. Okay. So now notice there's this section here, 1. We got section here between these two things. Section 3 between these two vertical asymptotes and this section here. All right. So the ones on the outside are going to have our normal looking curves that we normally have. On the inside, we're either going to have like a parabola looking thing or an S-curve looking thing. All right. Either have to go up or they have to go down. All right. Now, since there is no x-intercept here, all right, that means it doesn't cross. It's either going to be a parabola down or a parabola going up at some point. All right. So let's try in between here first. All right. Let's try in between here first. You're just going to have to plug in a point. So let's plug in 1. I have 2 options that's going to happen. It's either going to go up towards the asymptote or down towards the asymptote. So when I plug it in, if I get a positive, it's going up. If I get a negative, it's going to go down. So if I plug in 1, I get 2 times 1 is 2, 2 minus 1. I get a positive there. If I plug in a 1, I get a positive. 1 minus 3 is a negative. That is a positive, which means I get a positive times a negative is a negative. Negative times a positive is a negative. So it's positive or negative, which is a negative, which means it's going down. All right. Now, I'm going to do the exact same thing, but now plugging in, what's between 1/2 and 0? Well, how about a quarter? All right, we're going to plug in a quarter. So 2 times a quarter is a half. A half minus 1 is a negative. It's a negative a half. So then I get a quarter, that's a positive. That would give me a negative positive. So it's negative again on the bottom, but a negative over negative is a positive, which means this is going up. So I have a little S-curve looking thing there. All right. Now let's do here. You could plug in a point like 4. However, since this one is going down, this one has to be going on the top. And you could plug in 4 and you would see that it'd have to be positive. All right. Now, most likely, since this is going up, most likely this is down here. But let's just plug in a point and see. Let's plug in -2 and see where that is at. All right. So if I plug in, let me just erase this so you don't get confused. All right. So if I plug in -2, 2 times -2 is -4. -4 minus 1 is -5. All right. Then I get a -2 times -2 minus 3 is negative, what is that? -10. All right. And then -2 times -2 plus 3, is 1. So what I get is -2 times negative, which is a positive 20. All right. So I get -5 over 20, which is -1/4, which means it's right here somewhere. All right. It's not going to cross. If I went in, since this is up here, it's not going to be up here. So it just means it does something like this. Now, if you wanted to, you can test a -1 out and you would see it's going down just like that case. All right. And then finally, if this is going down here, am I going to draw it here on the bottom or the top? No, you're going to draw it up top. It looks like that. All right. So I know it's the first time you saw one like this. All right. But, it's a good problem. I would expect possibly to see one like this, but it might be called something that has the initials of EC. All right. All right, so now let's move on to number 11. Okay, so now we don't have to graph this. All right, hence the directions that say do not graph. All right, we just need to find the vertical asymptote, horizontal or slant, x-intercept, y-intercept. All right, so let's look to factor the bottom. Can it factor? Sure can. X plus 1 times x plus 3. So I have two vertical asymptotes. They're going to be at x equals -1 and x equals -3. All right. Didn't say this problem, but this symmetry, let me write that in real quick. This symmetry is none. All right, you can tell it's not symmetric. All right. Horizontal or slant, what do we have? Look at the degree. When I look at the degree is 2 on top, 2 on the bottom. That means they're the same. So you take the leading coefficients, 2, and what's there? It's 1. So 2 over 1 is 2. So I have a horizontal asymptote, and just circle that for me when you do the problem. Y equals 2. All right, x-intercept. You set the top equal to 0. So 2x squared minus 3 equals 0. So I get 2x squared equals 3. I get x squared equals 3 halves. And I take the square root of that. All right. So that is plus or minus root 3 over 2 comma 0. And quite honestly, because I do teach calculus, we don't make you rationalize that. But you probably should here, which is the same thing as root 3 over root 2. You multiply top and bottom by root 2, and you get the plus or minus the square root of 6 over 2. Quite honestly, if you just wrote plus or minus the square root of 3 halves, I probably wouldn't take off. But don't tell any of the other Algebra 2 teachers. All right. Y-intercept, we plug in 0 there, so that's gone. 0 there, that's gone. 0 there, that's gone. So it's -3 over 3, which is -1. 0, comma, -1. I'm assuming that everyone's hopefully making these as points. If you don't on the quiz, you'll get points taken off. Make sure you always label them vertical asymptote x equals and horizontals as y equals. All right. Now, 13. All right, 13. We have something that's larger on the top. All right, so this is going to be probably a slant. We can try to, let's see, take out an x, and that gives me 4x minus 5, which nothing cancels out, so it's definitely not a hole, so it will be a slant. We have a vertical asymptote at x equals -2. We will have a slant asymptote at, let's see, do a little synthetic, -2, 4, and -5, and 0. Bring down a 4. 4 times -2 is -8. That's -13. I don't care about the remainder. So it's y equals, make sure you have a y equals there, 4x minus 13. X-intercept, we set the top equal to 0. So we get two answers, 0, 0. And then 4x minus 5, I said equals 0, and get, what is that, 5/4, comma 0. And then the y-intercept, I put 0, 0 there over 2. I get 0 over 2, which is 0, 0, which makes sense because whenever the x-intercept is 0, 0, the y-intercept is 0, 0. And there is number 13. All right. So we moving on to the last page. All right. So we do 15 now. This is what we started off doing, with solving inequalities. And this would be by hand. All right. This would be by hand. All right. So, so let's get a marker up. All right. So when we do this, first we make sure it's set equal to 0. It is set equal to 0. All right. So we want to find the critical values. All right. All right. Remember, the critical values are where the top equals 0, which in this case is 0, and where the bottom equals 0. So if I added 15 and taken the square root, I would get plus or minus the square root of 15. All right. So we then make a number line, and you put those critical values on the number line. Positive root 15 is over there, Now, what is positive root 15? 16 would be 4. So this is like 3.9 roughly. You just need to know that when you're plugging what numbers to plug in the interval. So this is roughly negative 3.9. All right. So we're going to plug in and see where it's positive or negative. So let's start here. Let's just plug in like negative 5, for instance. Okay. We know that's definitely there. So that's negative 5, which will give me a negative, over negative 5 squared is 25. 25 minus 15 is a positive. A negative over positive is a negative. All right. Then we want to pick something between negative 3.9 and 0. All right. So I can just plug in 1. All right. So if I plug in 1, all right, negative 1, sorry, I get a negative over negative 1's 1, 1 minus 15 is a negative. Negative over negative is a positive. If I put a positive 1 in there, I get a positive over a negative, which is a negative. If I put in like 5, I get 5, which is positive, over 25 minus 15, which is a positive. Positive over positive is a positive. So then I just look. I am looking for where it is greater than 0. What intervals are we greater than 0? Here and here. All right. So it is from negative root 15 to 0. And these are all in parentheses because it's just greater than, or it's no greater than or equal to. Union positive root 15 to infinity. All right. And there is our answer for 15. All right. Now, last two problems. We have 17 and 19. They're true and false. So the domain of f of x is equal to 1 over x minus 9 is x equals 9. Is that the correct answer? Is it true or false? No, this is false. All right. Why? Because it's everything but 9. All right. The only thing that it can't be is 9. So you would write that as negative infinity to 9. That is an awful infinity sign. And from 9 to infinity. All right, that should be the correct answer. That's all you have to write to say why. All right, and then the last one, 19, the x-axis is a horizontal asymptote of the function f of x equals x squared minus 3x plus 5 over x cubed minus 9x. All right, horizontal asymptote you get by looking at the degree. So here it's 2, on the bottom it's 3. Whenever it's larger, on the bottom we have a horizontal asymptote of y equals 0. Y equals 0 is the what? It is the x-axis. So this is true. All right. All right. So I hope you guys, if you have any questions, if you had any questions, I hope this video cleared it up. If you still have questions, please reach out and I will try to clarify things for you. We will be doing more practice with this, more review. Like I said, be ready for a quiz on Wednesday. All right. Thanks, and I'll be in touch, guys. See ya.